Let's say we've got this 5 to the second power. Let's label these pieces here first of all. Label these parts here. Now where did that go? Still isn't right. What is that? Alright, under exponents, let's jot this down. This little number up here is the exponent. We also call that the power. And this big number here is the base number. Please note that exponents are not, this is not a multiplying of 5 times 2. It's 2 5s times themselves. In other words, it's this. The exponent tells you how many bases to multiply together. How many bases to multiply together. Okay, so this says that you're going to multiply together 2 5s. So the answer to that is 5 times 5, and that equals 25. In the world out there, there's something that's called exponential growth. And what that means is, 5 times 5 is not necessarily a big number. But if you were to make this to the third power, then you're multiplying 25 by 5, which is 125. And again, not a big number, but it's getting bigger. If I multiply that by 5 again, I get 625. If I multiply that by 5 again, this would be this is to the third power. To the fourth power would be this. To the fifth power, you're talking 30,000 or 30,000 or 3,125. Okay, so exponential growth means it starts growing slowly at first, but then as you keep going, it gets bigger, faster, and faster, and faster, and faster. It's kind of just like population. If one couple has just 4 kids, that's not very many. But if each of their 4 kids has 4 kids, now you're talking about 16 people, and each of those 16 had 4 kids, and you're 64. The farther you go down the line, the faster it grows. All right, Luke?
Will we ever have that? And then
What?
The exponent growth?
Exponential growth? No.
Yeah.
I mean, no, whatever. What about 3 to the third power? And again, please get it out of your head that it's 9, because it's not 9. It is 3 3's times themselves. 3 times 3 is 9, times 3 is actually 27. Okay, or maybe, 2 to the fifth power. Okay, 2 to the fifth power is 2 times 2 times 2 times 2 times 2. 4, 8, 16, 32. 2 to the fifth power is 32. And you don't want to do powers too much of big numbers, because it gets, if I asked you to do 9 to the fifth power, that's a lot of multiplication there. Because if you sit down and do it, 9 times 9 is 81. 81 times 9, 729. 729 times 9, it's 6,000 something, whatever, and 6,000 something times 9 is 54,000 or something. So, like I said, the bigger the numbers are, the quicker they get bigger. Now, the nice thing though is something that you need to understand is this: tens are always very easy to exponents. Tens are always easy numbers to take exponents of, because there's a little pattern that you'll see. By the way, anything to the first power is itself. Let's write that down. Anything to the first power is itself. So 10 to the first power is just 10. 10 to the second power, which is 10 times 10, is 100.
Well, you just add a 0.
10 to the third power is 1,000. 10 to the fourth power, and there you can kind of see the pattern here. Exponent, zeros, exponent, zeros. 10 to the seventh power will be a 1 with 7 zeros after it. Jacob?
In our math book, will it ever show us more than the third power?
Yeah, they might give you a 2 to the, 2's they'll go to the fourth power.
Yeah, I
Occasionally.
mean bigger numbers, 9, 11.
Well, 9, probably not to the third or fourth power. They try to keep it manageable, Jacob, because you are only in 6th grade. Later on they will. So that's the whole exponent thing. They might ask you something like this. What is 2 to the third power times 5 to the third power? Okay, and there you're just going to have to do it out. 2 times 2 times 2 is 8. And you're going to multiply that by what 5 times 5 times 5 is, which is 125. And then 125 times 8 is 2,000. Is that right? No, just 1,000. All right. Problems or questions, because we're just about done. Or maybe we are done. Yeah, I think that's good enough. Good enough.